Okay, so I want to talk about the critical period for weed control. Okay, the sort of questions we have is how long should whole weeding be delayed before there is a crop yield loss? Is it 1 up to 6 weeks, or how long must be a crop be free of weeds to prevent crop yield loss? Is it 1 up to 8 weeks? The current weed control practices under smallholder farming environment as follows. You could have weeding at the wrong time, weeding in the wrong places, too much weeding, or not weeding at all. Of course, there are some who are efficiently weeding. Now, if we look at the life cycle of a crop, we can identify two periods. The first one is when weeds do not compete with the crop. That is the first few days after crop emergence. There's very little competition. Then the other part is the days before the crop reaches maturity. At the end, there's also no competition. But in between, that is where there's competition. So there's a period when weeds compete with the crop, and that period ranges from 2 weeks to 6 weeks after crop emergence. What it means, if you are managing weeds and if you are doing it outside this period, then it's difficult to maximize yields. So the critical period for weed control starts from the time when a delay in weed control results in significant crop yield losses and extends to the time when weed control does not result in significant effects in increasing crop yield. Probably let me explain this graph. Critical for weed control. Now, if we are to establish critical period for weed control, we need a set of treatments we can have weed where we can have 0, 2 weeks what we call what we are going to do, we are going to allow weeds to grow with the crop for, let's say, just 2 weeks. Then we come and control. 4 weeks we come and control and make sure everything is clean. We can do it up to 8 weeks. Where we are saying 0, it's actually no weed control. There will be weeds throughout the whole season. Then we've got another set of treatments, weed free. Treatments 0, 2, 4, 6. And 8 weeks. Here we were saying 0 with we were saying 0. Actually, this is where we are having weeds throughout. Here we are saying 0 weed, it's actually no weeds, right? So we will then measure yield. After measuring grain yield, we then plot graphs, time versus grain yield for weed treatments and for weed-free treatments. So our graph may be like this. This is time in weeks. Maybe up to 8 weeks. This is crop yield. So if we delay weeding, probably at the beginning there may be less changes. Let me use a different color. So here we are delaying weeding. Right. We call this the weed period. And for the weed-free period, yield will increase. This is the weed-free . So if we are giving the crop a weed-free environment and we are increasing that period, we tend to increase crop yield. And if we are delaying weeding, follow that red curve, we tend to decrease yield. Then our critical period, if we draw a straight line here, we may say 5% yield loss here. It's not critical. Right. We may say where we have marked, we have sufficient yield, or that is our target yield. This could be in tons per hectare, whatever. Then when this line meets these 2 points here, this is the critical period for weed control. What it means is that at this position here, weeds are not competing seriously with the crop. And also at this position, there's also less competition. Critical competition is occurring here. So we can use these treatments to identify the critical period for weed control, and we can use this as a model to identify when we should control weeds. And on this model, from point A, I will indicate point A to B. Usually A to B is 2 to 6 or 8 weeks. And this is the critical period for weed control. Now, we are going to find out that this period can be affected by a number of factors. So it can vary this period. So this is how we obtain this diagram, and it indicates the critical period for weed control in any crop. This was the critical period found in soybean by Thomas and Van Lindet. And these are the sort of treatments which I was trying to explain for weed period and weed-free periods. This was proposed by Nieto 1968, Zimdar 1998, and Nevik et al. Also worked on these models recently in 2002, which is not very recent anyway. So let us look at the data on critical period for weed control in Zimbabwe. In most cases, the critical period of weed control starts from 2 weeks after crop emergence and extends to 6 or 8 weeks after crop emergence. For example, 2 to 6 weeks in soybean, as established by Thomas and Van Lindet in 1980. But in winter cereals, it has been hardly determined. Probably it's because the weeds are killed by frost. Soybean crop infested with weeds. So let us look at the effects, the factors which can affect that model which we have established. Number one, period of weed seedling emergence relative to crop emergence. Weeds that emerge, that germinate before crop emergence are highly competitive. Therefore, that model may not work, but it may work with weeds that germinate with the crop. Weeds that germinate with the crop could be also highly competitive. Weeds that germinate after crop emergence, less competitive. Probably that model may also not work, because you may find that weeds are not harming your crop. Weed density. Remember, there's a minimum weed density which can affect crop yields. What we call weed control thresholds. As long as the weed control thresholds has not been reached, this model may not work. But with high densities, then the model can predict that we should come in and weed from 2 weeks and end the weeding process around 6 or 8 weeks. Crop density. Increasing crop population may also affect weed populations. In other words, we could manage weed competition through crop populations or crop density. Weed species. Weeds may have different competitive abilities, so it depends which weeds are prevailing in the field. For example, Rapoco grass is more competitive than Mexican clover, pigweed more competitive than blackjack. So the outcome depends on the weed species. Crop species and varietal effects. Barley could be outcompeted by rye, wheat, and oat in that order. So crops which tolerate weed competition may suppress weeds, and it affects this model. Soil and climate factors, things like soil fertility, low N, P, and K, we can have serious competition for nutrients. soil moisture and rainfall. Drought can also cause serious competition. So weeds have to be removed from 2 weeks after crop emergence. In a wet season, Thomas indicated that you could delay by 8 weeks without harming the crop. Soil pH, under low soil pH, there is serious competition in maize. Time of planting is important. There are some farmers, after the onset of rains, they allow weeds to emerge. This is the first flush of weeds, which is highly competitive. They destroy that flush using plowing, then they plant on the second flush, which is less competitive. And under that situation, maybe farmers could delay weeding by 4 weeks without harming the crop, because the crop has been established on the second flush of weeds. In flay areas like Chiwota and Masvingo, like now, farmers have already planted in flay areas. They planted in August, and their maize has already emerged. And we don't have rains, which means we don't have weeds. Their crop could be on a weed-free area. So when the rains come, probably the weeds will not compete with those crops. So weeds do not emerge because of dry soil surface. So the model which we are talking about may not work under this scenario, where planting has occurred in August or September. You may be interested to know that we can manage weeds through crop density and rectangularity. For example, square planting can reduce weed competition. There have been studies to that effect. So you could read this paper, which showed that you can just manipulate weed density and sowing pattern to reduce competition. Yeah, these are the results they were obtaining. I don't want to preempt them. I encourage you to go and read this paper. You may find that interesting, especially the issue that we may not need to handle it if we know how to use the square planting and the right variety. So we can summarize this. We have just discussed the critical period for weed control in crops, which can range between 2 and 8 weeks from crop emergence, but this is variable. It is influenced by a variety of factors, and there are 8 of them. Number 1, period of weed seedling emergence, weed density, crop density, weed species with different competitive abilities, crop species and varietal effects. Soil and climate factors are important. Soil pH, cropping practices, time of planting, and also planting patterns like use of the square planting. Together with the variety, you can minimize competition. So this is it on a critical period for weed control. So when we are managing weeds, there are 2 issues. We should know the weed control thresholds, the competitive abilities of the weeds and the crops. Also, time of weed removal is very important. So this is it.